This lecture is on normally lecturing class, and it's about probability applications of counting principles. It's basically sort of a wrap up and a finish up for what we've been doing in the earlier sections in Chapter 8. I do want to remind you as we get started, though, that you still need to know all of the things that led up to this section. For instance, you still need to know the basic probability principle. If E is an event and S is its equally likely sample space, the basic probability principle says the probability of the event E occurring is given by the number of ways the event can occur divided by the number of elements in the sample space. Again, this is old stuff, things you already know, nothing new here. The product rule for probability, that says the probability of the intersection of two events is given by the probability of one of the events times the probability of the second event given the occurrence of the first event. And if it happens that those two events are independent, then you can drop the conditional part and simply get that the probability of E intersect F is the probability of E times the probability of F. Again, things you already know. You can extend this, of course, to more than two events, although I'm not doing it here. The multiplication principle, it simply says that if n choices are to be made so that there are m sub I ways of making choice I, then the whole series of choices can be made in m1 times m sub 2 times m sub 3 all the way out to m sub n number of ways. In other words, if you're making a whole series of choices and the m sub i's count how many ways you can make each of those individual choices, then the whole series of choices together can be made in the number of ways as represented by the product. And again, you already know this. You also know about permutations. The number of permutations of n things taken r at a time is n factorial divided by the quantity n minus r factorial. And that counts the number of ordered arrangements of n objects. And finally, combinations. The number of combinations of n things taken r at a time, and it can be written in several different ways. It can be written with the capital C and the subscripts on the left and the right of n and r. It can be written with this parenthesis notation, n on top, r on bottom, and it can be written just sort of like the permutation notation, replacing the p by a c. And in any case, however you write it, the number of combinations of n things taken r at a time is n factorial divided by r factorial times, and again, this n minus r represents the difference between the top number and the bottom number, factorial. And that counts the number of unordered groupings or subsets of objects. In other words, when order doesn't matter. So you should know this all going in to what we're really going to talk about today.